Having seen the motivation for regular expression and couple of examples, let us now develop a formal framework which will help us to convert a given regular expression into an equivalent NFA. Similarly, we will also look at a procedure which will convert a given NFA to an equivalent regular expression. And this way we will come to know that class of languages accepted by finite automaton and in particular non-deterministic automaton with epsilon moves, without epsilon moves, deterministic finite automaton, and the sets that are represented by regular expressions, they are all one and the same. So we shall now discuss how to convert a regular expression into a non-deterministic finite automaton. Remember, any regular expression, for example, we saw an expression in which every string had this pattern in it, meaning set of all strings over 0, 1 containing 1, 1, 0. So now if you look at any regular expression, the allowed operators are star clean closure and the union operator or the concatenation operator. Now if we define how to convert RE to NFA for each of this clean A star or closure operator or union or concatenation, then we can simply use those as a module to build an NFA for this. So what am I saying? If you have just 0, then an equivalent NFA is, it will have two states and just reads 0. If the expression is 0 plus 1, then it says the automaton, it either reads this or this, which means it may either read a 0 or it may read a 1. Now you have to choose between these two because it's either or this, but not both. So what we do, this is where the epsilon NFA is powerful, because epsilon is helping us in getting the design. So this is helping us. So what we do, add epsilon over here, this will be our final state. Now this clearly tells you, starting from here, without reading anything, you can either take this branch or this branch. One branch says accept 0, another branch says accept 1. Fine, so this automaton clearly tells you that if we take this path, then we accept 0. If we take this path, we clearly accept 1. So now, how do we represent something like 0, 0? I have an automaton for 0. Then I have another automaton for 0. You can combine them directly, or you can even introduce an epsilon to combine this. You can give this as an automaton, or you can simply say I have 0, final state. Now we may come across 0 star, so that says 0 or more number of zeros, so one can do like this. We may come across 0 plus 1 star. So 0 plus 1 star, take this as a package, meaning we have 0 and we have 1 epsilon to this, epsilon to this. Now what is that we want? So we want 0 plus 1 star, which means without reading anything you may go to a final state. So our epsilon transition from start state to this, or you may get into the module, meaning you may read either 0 or a 1. But this one can do any number of times, so which means another epsilon from final state to this. So what is this telling us? Suppose we want 0 plus 1 into 0 plus 1 into 0 plus 1. And from this let me take 1, from this let me take 0, from this let me take 1. So the first time when we go here, we take this 1. Then without reading anything, we come to the start. Then we take this branch, read 0, and then come back, take this branch and read 1. And if it is epsilon, meaning 0 copies of 0 plus 1, then simply take this branch. And if it is 3 copies, in that first copy we take 1, second copy we read 0, third one we read 1. Then first time when we get into this, read 1, come back using this, second time read a 0, come back, third time read a 1. So this automaton clearly reads 0 plus 1 star. Now we know how to do concatenation, we know how to do simple union and closure operator, simple operator, and the one involving this. Now one can construct an automaton for this. Now you see that epsilon NFA is giving you the design in quick time. Now one can use our standard procedure to convert this into NFA without epsilon, followed by subset construction to get DFA, or from this one can use epsilon closure method to directly obtain DFA. Fine, so let's construct an NFA for this and couple of more examples. So having defined the framework for operations such as plus, concatenation and star, let's build an NFA for this. So first let's construct 0 plus 1 star. So from this on epsilon we read a 0, or epsilon we read a 1, and another epsilon we reach. So this gives us 0 plus 1, and we need to go around this, and in case we want to directly read epsilon, we take this. One can also introduce additional states if required using epsilon, or we can have something like this. So this will give us 0 plus 1 star, followed by 1, followed by 1, followed by a 0. And now keeping this as the start state, simply copy this one. You can have epsilon, epsilon, and then read a 0, read a 1, then epsilon, epsilon to this. Now here again 1, 1, 0, you can directly read an epsilon, or one can keep reading this any number of times. Finally we accept the mission, or we accept the string. So now this clearly says 0 plus 1 star followed by 110 followed by any number of 0 plus 1. It could be an empty string, with that you stop, or you just read a 0 and then stop, or read a 0, come back, read a 1 and stop. So maybe you can read 010 from this, followed by 110 from this, then maybe nothing, or 010 110 followed by 110. Now this clearly gives you the automaton using NFA. Now one can build a non-deterministic mission without epsilon and subsequently go for subset construction to get DFA. For certain examples, one can directly get, for example, this one we can say stay at Q0 and read any number of zeros and ones, and followed by 110, we read a 1, we read a 1, we read a 0. Then when we reach here, we continue to read any number of zeros and ones. This is a non-deterministic mission because on 1 we go to Q0 as well as Q1. Now one can employ subset construction method to obtain an equivalent DFA. But this gives us a framework, which means any expression, however complex it is, you can always break that down into concatenation part and things involving union, clean closure, things involving just union, and for each of them take the appropriate module, attach them, you get NFA with epsilon for the required language. So like this, let's look at a couple of more examples. Consider this regular expression 0 star 1 star, to that we apply a star. Now let's construct an NFA for this. For 0 star it is like this. We may read an epsilon and reach here, or we may read a 0 and come back on epsilon and continue to read any number of zeros. Then after that it is 1 star, so we read a 1, okay, and then we reach this state. Now from this one can read an epsilon and reach this, or one can also come back and do this. Now let's see what happens. Now this says 0 star, this says 1 star, but because of this, are we missing something? For example, I can read 0, then I can read 1, then I take this epsilon and then take this epsilon and read another 0 and follow this one. But we are supposed to express 0 star and 1 star, leave the other star. Now, is this part capturing 0 star? Yes. Is this part capturing 1 star? Yes. But the moment you combine, strings like this can be accepted by the automaton. Okay. So what we do, first let's focus on 0 star 1 star. To ensure that this does not happen, what we do, we just follow module by module. For this 0, you use this module, come back, then you take one epsilon, and after that you read a 1, take this epsilon in case 0 copies of this, come back on this. Now this part clearly reads 0 star, this part clearly reads 1 star, and there won't be any confusion like the one we had before. Okay, so when you have this kind of concatenation, one has to be careful, but it is always safe to introduce one epsilon between two expressions, because this itself is a regular expression, this itself is a regular expression. To separate regular expression R from S, introduce one epsilon, and that way what we obtain will not accept strings that are not part of this expression. Okay, so now let's look at our original expression 0 star 1 star, this. Now that this accepts 0 star, this accepts 1 star, so what is that we need? We need 0 star 1 star to the power another star. So which means without reading anything, I should reach the final state, that's 1, and from final state I should come back and read a couple of more zeros and ones. So I read one epsilon. So what I do, starting from here, you read this epsilon, so you reach this, or read 0 star followed by 1 star. You may want to continue this because it says 0 star 1 star this. So to continue this, we come back to the start state on 1 epsilon. Fine, so this clearly tells us that 0 star 1 star and any number of times the 0 star 1 star. Fine. Now let's see a couple of strings accepted by this automaton. Let's assume 0 star 1 star, 0 star 1 star, 0 star 1 star, something like 3 copies of this. Now from this, let me take 0 0. From this I am taking epsilon. From this let me take 1 1 1. From this epsilon. In this what I do, let me take 1 copy of 0 and 1 copy of 1. That's all I have. Now what this says is, you go over this, you get 2 zeros, followed by go over this, you get 2 ones. Then when you come back, you get to see that you can read a 0, you can read a 1 and accept. Fine. So you can look at it this way, or you can also look at it like 2 zeros, then take this epsilon and come over here. Next time when you come inside, you read 3 ones, then go out. Next time when you come here, you read a 0 followed by a 1. Correct? Now, because you have 2 interpretations, right? In one go itself, you can read, or this in the first go, this in the second time, this in the third time. Okay. Now the same thing, look at it this way. Can I write like 0 plus 1, 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 0 plus 1. And from the first one I take 0, second one I take 0, third one 1, 1, 1. From this I take 0, from this I take 1. So now a string that you could generate out of this, same thing can also be generated using so many copies of 0 plus 1. So which means what? We get to see that this is same as 0 plus 1 star, because what you generate, the same thing can also be generated like this, which means this expression is equivalent to 0 plus 1 star. So what we achieve through 0 plus 1 star can also be achieved using 0 star 1 star, the whole star. So like this, one can come up with couple of identities. So given a regular expression, we want to simplify to obtain another regular expression, then things like this will be of use. We have identified one identity. Like this, let's explore some more.